Is figuring out the limiting. We took our limiting reactant grid and we're going to repurpose it. We're going to use the front part of the grid. This should also be here, but it wouldn't let me cut it. So it goes 1 mole of chloral here on the bottom. We recycle from the original grid, and all we're going to do now is we run it back to, now we go from the limiting reactant to the excess. It's on the same side because we're going to get used. We go from here to here. It's going to tell us how much chlorobenzene we used, and then the last step is subtraction to find how much is left over. So we're going to use this grid. So we go here, 1 mole of this is equal to 2 moles of chlorobenzene. That's where it's coming from. So I'm going from here to here. So 2 moles of C6H5Cl. Boom. And here's how it works. We go 1 mole of C6H5Cl is equal to, and then what's the value of chlorobenzene? The molar mass of chlorobenzene from before is 112.6. So I'm going to go back over here. And where did my little grid go? I lost it. 112. Let me shrink this down. 112.6 grams of C6H5Cl. See, I'm right on my units. If I do it, you do it. There we go. Now, then I'm going to run this. This is going to be my use grid is essentially what I'm going to get. So this is my use grid. So I'm going to run the grid. Let me pause it while I do the calculations. 741 grams of C6H5Cl. Boom. So I get 741 grams of C6H5Cl. That's how much is used. So then what I do is I just do this. I take the original amount, which was 1142, and I'm going to go 1142 as my starting value. It's also the one at the beginning of the grid. You can also look here if you want to check. It's also going to, because we said this is the excess, so we know there's a leftover there. You could grab it there too. You go back to the original problem, I don't really care. And we're going to subtract the 741. So I go 741 minus this. So I'm going to go 1142 minus 741. I get 401 would be my excess, right? And then last but not least, it's asking me for my actual yield, or it gives me my actual yield, and it's asking me for the percent yield. That's how much did I do. How do we do when we did the experiment? So I'm going to take the actual yield, because remember, here's the formula. You go actual yield. It's what you get in the experiment, kind of like what you get on a test when you take it. Up, the actual yield goes on top. I don't know why I split that like that. Morning fog. So the actual yield goes on top. I don't know if I can even use the eraser. Holy cow. Oh, whatever. Anyway, actual yield goes on top. Theoretical yield goes on the bottom times the 100, not the car, but the 100. And so I take the 200. Now remember, my theoretical yield was a smaller number at the end of the grid. That's why we care, the 1170. So I come back here. So I'm going to go 200 into 1170. It's going to be not the greatest yield in the world, times a Hyundai car, not the car number, 200 divided by 1170, boom, and multiply times 100, and I get 17.1 when I'm done. 17.1% is what I end up getting with that. And that is the problem you have to be able to do. So when you talk about reaction stoic, you have to be able to find the theoretical yield. That's where you use the two grids, pop in the givens, what are on the left-hand side. Left-hand side goes in the grid. We know the right-hand side is going to go in the formula. That's why it helps to organize it right at above. Some people do and get it right. Some people don't, and maybe you do. Whoops. Do it. Just do it. Nike switch. Ready? Nike switch. Just drew one. How fancy is that? Now, go over here, and I look right here. Then I take the limiting reactant, repurpose the grid. So this was all recycled, and I just added it because when you got to find used, you go from here to there. Limiting to excess. Finish the grid with that ratio in the molar mass. That's going to be used. Subtract it. You get that. And then actual over theoretical. That's everything you need to know for reaction stoic. Boom.